Good morning, everyone. Today, I'm going to explain the IPsec VPN configuration and how we are going to configuring an IPsec and what is the difference between IPsec and VPN. Sorry, not VPN. It's GRE tunnel VPN. So most of the people they are confusing about an IPsec VPN and an GRE tunnel VPN. So before of that, I want to discuss a few terms how they are using in our networking terminologies. The first one is ingress interface, egress interface. The ingress interface means while a traffic is coming to an interface, that means that inside interface is called ingress interface, and exit interface is called exit interface is called an egress interface. So coming to that GRE and IPsec, the GRE is a tunnel, means it is one type of protocol we are using for encapsulating the packets, and it is developed by Cisco. And GRE is used mainly when packets need to send from one network to other network over the internet or an insecure network. And this GRE virtual tunnel we are creating in between the two endpoints, mean the Cisco routers, and these packets are sent through an GRE tunnel. And also, it is important to note that packet traveling inside GRE tunnel are not encrypted, as GRE does not encrypt the tunnel, but it encapsulates the packets with the header GRE with GRE header. If we want to data protection required, again we have to use the IP security. Mean that IPsec. This IPsec in the sense both the phase 1 and phase 2, the ISEC KMP and crypto ISEC KMP. Both we have to use for providing that IP security. Of that, both of IPsec and also GRE VPN, GRE IPsec VPN. So, what is the main difference between an IPsec VPN and GRE IPsec? In IPsec VPN, we are configuring with an access list, and this access list we are going to applying in a crypto map. And this IPsec is only supporting for unicasting; it will not allow for multicasting. Coming to the GRE tunnel, here it will support for multicasting, and also we can you can configure dynamic routing protocols also here. It is not possible with an IP routing, mean that a static routing not required here. We can also configure with support of the both dynamic and static also here, because of it is allowing multicasting. So if the multicasting is not allowed, that means a multicast IP addresses mean like a 224.0.0.10, that is the multicast IP address of the ERP, GAGRP. If it is not allowed in that IPsec VPN, so the neighborship will not be formed, but it may happen in GRE, IPsec GRE tunnel. So first of all, I'm going to explain the IPsec VPN configuration with the router R1 and R2. Both these routers are configured with that serial IP addresses 192.168.32. Subnet. And the same way I configured with 10 subnet, 10 series of subnet for R1 LAN IP addresses, in the way 170.16. Subnet I'm using for the R2 LAN. So here The IPsec, in the sense, we are not creating any tunnel here. So we are assigning an IP addresses in the easiest way to the both of these serial interface and LAN interface, and we are going to configuring both of these crypto and ISAKMP. Mean that both are in the two phases. ISAKMP phase 1 and ISAKMP phase 2. What is the difference between phase 1 and phase 2? The phase 1 I'm going to configure in the ISAKMP, and the phase 2 I'm going to configure in the IPsec. So this here crypto and I as a KMP, just I'm going to explaining with that. First of all, I'm going to explain with IPsec VPN, and later we can configure the same one for GRE tunnel with the support of GRE IPsec VPN tunnel. So first of all, I'm going to configuring for IPsec for both of these router R1 R2. I'm pausing this video for a minute because I'm not configured any of the configuration of the both R1 R2. So just I'm putting on hold for a minute to configure the basic configuration of both of these routers, both of the R1 and R2. In the meantime, I configured both of R1 and R2. The physical IP address will I'm assign here both of the routers. Okay, let me check. 191.32.1, 10.1.1.1, 100.32.1, 100.32.2. Yes, both are same fine. Just I'm checking whether the other side, the other next hop is reachable or not. 192.168.32.1 is the local IP address and 2 is the other end. Okay, great. I'm able to reach on both sides. Great. So now I'm just configuring with R1. For before of that, just I want to create an crypto as a compute policy. So this is the crypto ICKMP policy is the first one I'm going to create in the R1. The internet this is for IKE1. We call it as normal in normal terms. We can call it an IKE1. The IKE is that internet key exchange. The IKE exists only exist means mainly to establish security sessions for IPsec. I mean not security sessions, security associations. It is called security associations for IPsec. And now we can start working on R1. So just I'm going to creating the crypto ISAKMP policies and all. Config T. I say crypto. I say policy one. I created a policy. One of the policy for crypto. The next one is authentication. What is authentication here? Authentication is a pre-shared key and hash. What is mean by hash? Here we can use uh, for both any one of the MD5 and SHA. The both of these are using for hashing algorithm, and also we are using for 3D ES. This is encryption method to use for the phase one, and the pressure key is mainly used for uh, to exchange the shared keys for an authentication method, like, and also authentication pre-share hasha, and also mainly what are those replace the policy one authentication pre-share hasha. Okay, these are the three commands required from here. And next one is I'm going to creating key. What is the key need to exchange? Crypto as a KMP key. What is the key here? I'm putting as an Cisco here. Cisco to the address. Cisco. Oh, Cisco key. Okay. Encrypted. So 6 I'm going to here, and Cisco. Yes, address to the next hop IP address I have to put here. So what is the next hop IP address here for R1? The next hop IP address is 192.168.32.2. 32.2. And crypto IPsec transform set. I'm putting a name here. So I'm putting what name to put? Myself. Oh, CCNP. CCNP I'm putting here with ESP SHA HMAC, and that again ESP and AES. What it is called? What are these? This ESP 3D ES are mainly for encryption method, and MD5 is for algorithm and transport mode. And this we need to create the transform set user to protect our data. So we named it as with CCNP. After creating this, I have to create an access list, and after that I have to create the crypto map. uh, Again, these both of these in the crypto map I have to assign the access group which I has to create the access list. I will place this under crypto map, and this crypto map I'm assigning in the serial interface. So in the same way I'm going to configuring on the secondary side also. So where we are now, so I have created a crypto IPsec, and now I'm going to preparing crypto map R1 to R2, and I'm going to give a number with IPsec ISAKMP IPsec ISAKMP. So here it is showing, the note is showing here, this new encryption map will remain disabled. So it is disabled until a peer and a valid access list have been configured. So here I created an crypto map only, but I forgot to create an access list. So first of all, I'm creating the required commands. As set peer means we are giving what is the peer it has to reach. So what about the peer? What are the other side number? It is 192.168.32.2, and I'm calling the transform set I created in previously. So I'm calling the same transform set here. Here mean with the support of set transform set. What I have to given the name of the transfer set is it is CCNP. And what I have to create then? So I have to create the access list. So in a minute of time I'm going to preparing. So access list I'm creating with standard access list. So I'm putting 101 one permit. I'm using the permit tool. I'm putting only permit. I'm not tuning any of the IP address and port numbers. Permit. What's next? The IP. I'm giving subnet only here because of here I want to allow from 10 dot mean that from the LAN of the R1 to communicate LAN of the R2. The same vice versa I have to configure reversely at R2. So I'm going to configuring it 10.10.10.0 because I'm going to putting a network only here, that is specific IP addresses with 0.0.0.255 up to means using that wildcard mask I'm using here. And next one is I'm going to allowing 170.16.32.0 to up to 0.0.0.255. Okay, accepted. So where I have to apply this one? The crypto map. So this is the one I have to enter into the crypto map. This one I have to enter. Okay, and match address. What is the number? It's 101. Okay, just for a safe side I'm checking configuration on both on the router R1 crypto IPsec KMP key Cisco address. Okay, IPsec transform set and PSP. Okay, crypto map R12 R2 IPsec KMP set peer match address set transform set CCNP. Now I'm assigning to serial interface serial 0/0 crypto map R12. Sorry, what I given? R2 R1 R1 to R2 R1 to R2 R1 to R2. Yes, you can see after giving the crypto map under the serial interface, it is showing that the crypto IPsec KMP on is on. In that it is on. On the other side also, I'm configuring the same one. Config T crypto IPsec KMP key. What is the key enter here? I forgot the key. What is the key enter here? Key Cisco 6 Cisco address. What is the address? The address is 192.168.32.1. And before that I forgot to configure crypto IPsec policy IPsec policy 1 authentication pre-share hash SHA and exit crypto IPsec transform set CCNP ESP SHA C and ESP AES. So before creating that crypto map I have to create that access list. So I'm going to creating the access list with extended access list because I'm using the 101 to 101 IA 101 101 IP permit IP from I have to allow from 172, right? 172 only, right? 172 dot 16 dot 0 dot 0 or 32 dot 0 dot 0 from wildcard mask 255 and 30 10 dot 10 dot 10 dot 0 0 dot 0 dot 0 dot 255. Yes. So now I can create a crypto map here R2 to R1. The number is what is the number I have given here? 10 10 10 I, IPsec 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 okay, and I'm putting the set P. What is the peer address? The peer address is 192.168.32.1. Match address 101 set transform set. I given the CC and P. Just I'm calling the transform set here. Then yeah. Same way I'm going to entering this. I'm calling config T interface serial 0/0. I'm calling the crypto map under the serial interface. Crypto map. What is given name here? R2 to R1. Yes, you can see here the IPsec is on. Now we have to check show crypto to IPsec SA. Yes, address okay, none. No, there is no packets, no packet. Show crypto to IPsec SA. No, it was not created. Where the problem is existing then. Show crypto IPsec SA. No, why? Why the crypto map was not created? No, not crypto map. Why the IPsec VPN was not created? Because of I forgot to configure the routing. Because the R2 don't know about that R1's LAN interface. So I forgot to configure that interface routing and routing. So if I want to reach IP route uh, 10.10.10.0 255.255.255.0 I have to use. Then next to be 192.168.32.1. And vice versa, I'm going to enter in that R1 IP route 172.16.32.0 255.255.255.0 with 192.168.32.2. So just I'm checking whether I may able to reach to 172 dot series 32.1. Yes, I will reach. Ping 10.10.10.1. Yes, I will successful. Now we can check it. Show crypto ICKMP still it is not showing. Why? But there is no issue is showing on both of the ends. Show crypto to ICKP Security Associations. No. Why it is not showing? Show crypto ICKP Security Associations. No. Where is the problem existing? Sometimes if we ping to that destination tunnel, mean that destination destination IP addresses which we are going to setting that peer informations, just want to check by pinging ping what is the IP address of that? Show IPINT, not here. Show IPINT brief. If I want to ping 192.168.32.1 with source of not to the serial interface, and I want to ping to the LAN interface. That one source 172.16.32.1. So I'm able to ping. Now show crypto SCMP security session. Yes, here you can see that the security session was showing fine now. What about this side? Show crypto SCMP SA. Yes, here you can see uh, the IPsec VPN was established between R1 and R2 on the both sides. So here the state is showing idle. Idle means it is not, there is no traffic is showing. So I want to put here it is same one to testing ping 10.10.10.1 repeat 1000 source of the source of 172.16.32.1 I think, right? Yes, I'm pinging. Still show strategy showing QM ideally. Why it is? Show crypto IPsec SA. Yes, here you can see that inbound ESP is that encryption is formed with the tunnel 1. This tunnel is automatically created. We will not use any tunnel here. Let me check with why it is showing show crypto SKMP SA. Why it is showing ideal.